All right, so now we're going to look at a numerical and graphical approach. So we already did some graphical, but now we're going to do more of a numerical as well. So to begin with, you guys did the bell work, and I know you're so smart. You already got them. So for this one, how did you say it in words?
The limit of x as x approaches 3 is 5.
Perfect, right? What's another way I could say it?
As x approaches 3, f of x is 5.
Kind of. The limit as x approaches 3 of f of x is 5. Perfect. I'm not going to write that down. I think you're good. What is the significance of the limit of f of x as x approaches 3 equals 5 if we know that f of 3 equals 2?
Discontinuity.
Say it again?
Discontinuity.
Discontinuity, exactly, right? Exactly. There is a point of discontinuity.
Sir, what's that word? Between discontinuity and a hope, or they?
It's the same. So basically, what would it look like if we were to graph this? Okay? And we know that like at 3, it's supposed to be 5 for the limit. What you would do is like put a little hole. And then at 2, that's where you'd have your little filled in dot. I'll make that more obvious. But that's basically what we know is going on, right? Is that there is some hole there, the discontinuity, and the graph itself is down there. Does that kind of make sense? That's what we know is going
Yes, sir,
on.
how do you know that the hole is the one in the limit? Or
Because the limit is what we're approaching, whereas this is what we're approaching. So I have our equals down here, and this one is the hole because it's still.
and the other one can't be.
Okay, so let's do some real work, shall we? Hopefully. All right, the equation of the function graph to the right is that. I'm not going to read that. The coordinates of the hole in the graph are -3 and 7/6. Okay? So that hole that's right here, that's where that hole is. Okay? So then, in pre-calculus, the way that we would say these things, and then we're going to learn how to write it in calculus notation. So as x approaches -infinity, the graph of f of x, so if we think about this, as we approach -infinity, we'd go like this way, right? What would we get close to?
0.
2. 2, right? The asymptote, the horizontal asymptote, right? Okay? In calculus, what we would say is the limit as x approaches -infinity of f of x equals 2. So in other words, when we're looking for like the limits at infinity, that's going to be like what's going on at the end behavior, right? What's going on to the extremes. Okay, what about if we go to the extreme right? As x approaches infinity, the graph of f of x approaches 2 as well. And this is exactly the same, except that this time it's not -infinity, it's positive infinity. Okay? Now, what about when we approach the hole? As x approaches -3 from the left, the graph of f of x approaches, what was it?
1.
No.
-3.
Thank you. Somebody read the page. It says right on there, right? The hole is at 7/6. -3, 7/6. And then the way we would write that in calculus is the limit as x approaches -3 from the left, so I need a little negative up above, okay, of f of x equals 7/6. Now, if I approach it from the right, did it change? No. So in pre-calc, we'd still just say it approaches 7/6. The limit changes because now instead of saying from the left, we say from the right, so we need the little plus sign up above the 3. Okay? Of f of x equals the same thing, 7/6. Cool? Now for these next ones, I'm going to scroll up so you can see it better, okay? So now, as x approaches 3 from the left, the graph of f of x, let's go look. So what is 3?
A vertical
Vertical asymptote. And from the left, which way are we going?
negative.
We're going to get down to -infinity. Now, before we write that down, let's look at the other one too, because we know it's going to ask us from the right. What's happening on the right side? Positive infinity. So from the left, we went to -infinity, and from the right, we went to positive infinity. Our limits are going to be the limit as x approaches 3 from the left, so the little negative up above, of f of x equals negative infinity. And then the limit as x approaches 3 from the right, so the positive, of f of x equals infinity. Okay? So based on what we've seen, how might you informally define what the value of a limit represents in terms of the graph? Like informally, how would you say that? What is the limit going to represent for a graph?
Where the direction it's going.
Where it's going. Exactly. Yeah, it's just like where it's headed to, where it's going.
Where it's go.
Actually, let's say, instead of it, let's not use it. It is terrible. Let's say where f of x is going or approaching.
We write that in the box or?
Not in the box. No, the box is going to be something else. Does approaching have two p's? I think
Yeah.
so. Okay. I was like, wait, does it? All right, then we're going to write the limit existence theorem in the box. Okay? You wrote that in the box?
Yes.
Oh, that's okay. We'll forgive you this time. All right, so our limit existence theorem is if the function at x equals a approaches the same value from the left and right, then the limit exists even if the function at x equals a is different from the limit or does not exist. So I'll let you write that. I know it's long, but if you read it and think about it, it makes sense. I hope.
So we just write it down and then we.
Yeah, sure.
It's hard to.
Hard to do both.
Yeah.
We good? Juanita's done. I think. Alrighty. So when you read that, does it make sense? No? All it's saying, right, is that if it's approaching the same thing from the left and right, then the limit exists. Because if it's approaching two different things like we saw the other day, it doesn't exist. Right? That's all it's saying. Okay? If you want, you could think of it this way, Juanita. You cannot approach your home and the school at the same time. Would you agree? Go ahead, tell me how. I'm willing to be wrong. Because there is a way that you're right, so go ahead, tell me.
How is that the same? That your home is the school.
There you go. So if your home is the school, then you could be. And then the limit would exist. We'd all be sad for you, but it would exist. All right. Okay, let's do some graphical questions, yeah? Yep.
So we know like if the limit exists, where is like the limit? But how do we know where the point is going to be?
You'd have to have the equation. Yeah, you would need the equation. Okay. So we're going to consider the graph of g of x here. Okay, it's graph below. What kind of graph is that? Starts with a P? Piecewise. Thank you, Manuela. All right. What? So now what we're going to do, you guys are really excited about this question. All right. We're going to find each of these limits. If it doesn't exist, we're going to state why. Guys, what is going to be the reason why almost every time? I already told it to you.
To y values share the same x value.
But what's the reason that it would not exist? Because what?
If the limit doesn't exist, it's because the left side.
Yes, almost every time it's going to be because the left side does not equal the right side. right? Which is basically what we just talked about with the limit existence theorem, right? Okay, so let's look at the first one. The limit as x approaches -3 from the left. Here's our -3 from both, or from the left, I guess, or only the left, is 0.
But why don't we look at the disconnected one, like the dot also x equals -3 at the top.
Because it's not the graph. The graph is not up there. The graph is this line.
I thought those disconnected points in a piecewise graph also counted as a graph
They do, but it's not where the graph is heading in that time.
because it's past the asymptote.
No, because if we look here, the graph, like the trend of this graph is to move this way towards -3, sorry.
Okay, and that's just
And at -3, it's approaching 0. This is just a single point, like a pinprick. So it's not approaching anything.
okay.
It's just like an outlier.
Okay.
Okay? All right, let's actually jump down and do D. What about if we do the same thing, but from the right? Well, that means that we're going to go to -3, go a little bit to the right, move back, also 0. Amazing. All right, let's do -6. As I approach -6, where's -6? Over here. If I approach it, it doesn't say what side, so it's both sides. From the left, from the right. What do I get to? I'm at -4, right?
Wait, but why not look at the wait, oh.
So when I approach -6, the graph approaches 4, -4. All right, let's do -1 from the right side. -1 right here. From the right side, I go a little bit to the right. Martin, talk a little less, man.
I'm talking about the lesson. I'm talking about
I know, but you're talking so loud, you're talking louder than me. Okay. Ladies, who had a question?
I thought we were going down, so I couldn't.
I'm doing them randomly just to keep you on your toes.
That's what
It's okay, Camila. All right, so -1 from the right-hand side. What are we approaching? 2. I heard somebody say it.
Yeah, it's 2.
All right. Now, I want you to pay attention to these ones. The limit as we approach -4 from the left. Oh, sorry, just 4, the asymptote here.
It doesn't exist because it cuts the function off. It cuts the function off, so it doesn't exist.
So it's not the left side doesn't equal the right side. So I told you that would usually be the answer, and it's true, but you have to know that sometimes it's not going to be the case, and you got to use your brain. So here, the function literally just doesn't exist. There's no function between 3 and 4. Do you agree?
Yeah.
It doesn't exist at all. So we just say the function doesn't exist. So in this case, the limit doesn't exist because the function doesn't exist. Okay? Now what about from the right side? Let's go, since we're talking so much, I think Rebecca knows the answer.
what question?
Well, we're waiting for Rebecca, but she doesn't know the
What
answer.
letter?
F.
Is negative infinity.
Does she know?
She said that.
Well, say it so we can hear you.
Puse menos 2.5.
You're so quiet. Say it so that Sandro can hear you. Okay, yes. Sure. Right?
Yes, sir.
From this side, we're clearly going down to negative infinity. All right. So what's the limit at 4?
Also, it does not exist.
Exactly.
The theorem.
The left side and right side have to both approach. They don't. Therefore, it doesn't exist. You got it. Awesome. All right, now we're going to do -4 from the left and right. So -4 is right here, this line. From the right-hand side first, so we're going to go a little bit to the right of it, which would be like -3-ish, right? And we're going to move towards -4. What do we get to?
I put negative 2.5.
Yeah, I'd go with like -2.5. I agree. All right, now we're going to go from the left. This one's much easier. What do we get? -6. So far, pretty easy, right? We like doing it with graphs. Graphs are easy.
Es que yo puse 5. Mister, the printer is like that.
Why? What did it do?
Yeah, the printer you can't see
It
the
seems
numbers.
all the numbers are
All the numbers look the same.
On here?
No, on ours.
But on like this on the graph?
Yeah.
Okay, sorry. If it ends up being like that for multiple lessons, I'll print a new one.
Sir, the exam is going to be printed in the same printer.
I mean, they're all printed in the same printer, but it's okay. There we go. We're back. So, guys, what's gonna?
Are we gonna need a calculator for this one?
Yep. Okay. So let's take a look at this. We've got this function f of x. It's x cubed minus 1 over x minus 1.
Yes, sir. We need a calculator.
Okay. All right, let's have it. Let's do it this way. Martine, your table. Your table. I didn't even say you, man. You're not Martine. Why are you saying what? Ah, okay, fair enough, fair enough. Well, Matthias, it's okay. It's your table anyway. Matthias, Martine, all of you. Guys, you do 1.8. This table right here. Boys, I want you guys to do 1.9. Ladies, I want you to do 1.99. Matthias, are you comfortable going alone on 1.999? And I will do 1.9999. Okay?
Yes, sir. Right now, 0.9 infinity is equal to what?
I don't know, man.
What number do we round?
Let's go with like 4 digits. No, let's do.
So like 4.2764. 4.
I don't know, hang on. All right, boys, did you get it? What is it?
Is it 4.2764 or 6.
It's wrong. This too. 6.04.
All right, I guess we'll have to do it this way. Wait, is it cubed or is the whole thing cubed?
No, it's
It's that. That's right. Is that right? Yeah, that's right. All right, so you should have gotten 6.04, boys. All right, the first table didn't do so good. Let's find out how the second table did. You guys had 1.9, right?
6.51.
Oh, look, they know what they're doing. 6.51. I like it. Brownie points to table number 2. Ladies, let's see how you did. Oh, look at that. They're right. 6.95. No. All right. And Matthias, how did you do? Look at that. He's right. 6.995. And then what did I get? 6.9995. So I just added a 9 every time, right? I pushed back that 5. Okay? So, ladies, since you cannot stop talking, you may be the reason we get a, seating plan. But let's hope we don't. Carolina, what is happening as we approach 2 from the left? As we get closer to 2, what's happening? Emilio, you are not Carolina, man. What are we getting closer to? To 7. How would we write that, guys? We'd write the limit as x approaches 2 from what side? The left. Of, I'm just going to say f of x, but if you want, you can write out the whole equation. Equals 7. Look at that. Don't we love it? Love it. You guys ready to do the next one? You're already doing it. Amazing. All right. So let's do the next one now. Now we're approaching it from the right-hand side. So I'm going to start with like 2.2. And I get 8.04.
We use the same equation as the other.
Yeah, so it's really easy to do this in Desmos, guys, if you look, right? Because I write out the equation and all I do is I change it, right? So now I get 7.51. Then I do 2.01. And I get 7.05. And then I'm probably going to add another 0 in there, right?
We're gonna check the last one.
7.005. And then 7.0005. And so, Eulalia, what is it approaching? The x is approaching too. We already know that. So y is approaching. There we go. It's approaching 7. The way we write that is the limit as x approaches to positive. Okay? Any questions? You guys got it? You guys are so loud. You are a loud, not your table, these two tables. These two tables, quiet. Those two tables, well, actually, Benjamin, no. He's loud too. This one's approaching from the right, this one from the left. Yep. Yeah. All right, guys, how do we know, or what do we know about that limit?
7.
It equals 7, right? Or we can write. Actually, I'm kind of just writing the same thing, I guess. Yeah, I don't think that's what I wanted you to write, and I can't remember what I wanted you to write. Or we can write.
No, can we just write it?
But do we write it?
You know what? We could say this. I know, we could say this. Let's just go super simple and say we know that the left side equals the right side. Therefore, limit as x approaches 2 of f of x equals 7. I don't remember if that's what I wanted you to write, but I like it.
Just DME because you're dividing to.
I don't know, man.
What's the 3 dots?
Yeah, that's what I was
What did you do the 3 dots for?
Where? What 3 dots? Oh! Oh! Do you guys not know what therefore means? Oh my god! Who's been teaching you science? Go back and tell them they suck. No, just kidding. Don't do that. Go to, well, no, champ, you can tell him he's
Why
in
is
trouble.
therefore abbreviated?
I'll tell him today. I'm driving home with him. Listen, guys, they just mean therefore. In science, we use it all the time. The 3 dots mean therefore. I'm going to use it all the time. Because therefore is a long word. 3 dots is easy.
And is that like standard?
I'll tell him. I'm driving home with him
But
today.
is that something you?
I'm giving him a ride. It's a speaker pocket of me.
Is that something you do, or is that like standard?
Everyone does it. It's not just me, guys. That's.
Yes, sir.
I didn't know. No, but you know what's funny? We're from 2 cities in Canada that are like a couple hours away from each other. And they're rivals. Like all the sports teams are rivals. No, I don't hate them. I like them. Okay, good question. Guys, listen. In AP Calculus, it's not proper, but they like to do 3 decimals. Just do 3, always.
So when the limits of both sides are the same, we put that there.
You can. No, you can just leave this. That's enough. Okay, let's try the next one. We're so loud. Camila, go ahead. My dear, what do you foresee being the problem in the next one?
Sorry.
What do you foresee being the problem in the next question? What are you going to end up dividing by? We're going to divide by 0, right? So this is going to be an asymptote most likely, maybe a point of discontinuity, right? Because if we plug 1 in the bottom there, right, it's going to be bad. So let's go ahead. What was the first number there? I didn't even see it. 0.9? 8? All right, 0.8. We get 2.44.
Esto debe ser 2.998.
Then we're going to plug in 0.9. Whoa, what happened there?
Saldrá desde el 2.97.
Then we get 2.71.
2.30.
Then we're going to add another 9. What do you mean, what am I doing?
No, is that right?
2.970. Then I'm going to add another 9.
Wait, 2.19.
2.997. What do you think is going to happen next? 2.9997. All right, now on this one, we're going to work from the other side. We're going to start here and work this way, okay? So let's start with 1.1. Make sense? We're going to start with the one that's further away.
Aquí se approach 1, eso es igual a 3. Sí, porque mira que está desde la izquierda y también desde la derecha.
So we get 3.31. Then we're going to plug in 1.01.
3.31.
And we get 3.03.
Por otro lado,
Then we're going to add another 0.
2 por 2, 4. 2
And I get 3.003. And then 3.0003. All right, how do we express this using limits? Well, we could say the first side here, this was the limit as x approaches 1. From what side? From the left, right? Because it's smaller. From the left of f of x
Pues que esto es distinto.
equals
1 en
3.
1
And even before that, let's do this way. The limit as x approaches 1 from the right, because I want to show you what's really going on, of f of x.
Mister, is it approaching 1 or
It's approaching 1. And then it's, y or x? X we're approaching 1 from left and right, but the y value we're approaching is 3.
I don't know, X.
X we're approaching 1.
Es 1.
Yeah, from the left and right.
1 menos 1 es 0. 0 dividido 0 da
Okay, so we just say, like, because the left and right side are equal, we know that it's equal to, like, the limit as x approaches 1 from both sides, so it's 3. The limit exists, in other words. Yeah? The idea is to show you that they're both equal, and they're equal to 3, therefore, we know that it's true.
Es que bloquear es la E.
All right, what about f of 2 and f of 1? F of 1 is automatically undefined.
Based on what you have seen so far, so
Wait, why? How do we know?
Okay? So we know that, why do we know these things? F of 1 is undefined because it's over x minus 1. The other one, we just plug it in, right? 2 cubed is 8 minus 1 is 7 over 2 minus 1, 7 over 1.
Wait, but what?
Okay.
What
I think I did that too fast for Camila.
What
Okay.
you said about F1 being undefined?
Let me write it out for you. Let me write it out, guys. But I think it would help you guys. Benjamin, you're too loud. Boys, Simon. Guys, you're too loud, which is part of what makes it hard. Benjamin, I'm going to make you go for a walk real soon, buddy. Like, go for a walk out in the hallway, away from us. Okay? No, I'm saying I'm going to. I'm going to, okay? So just wait. Because the problem is, then people are not following. So just don't talk over me. Guys, this is the function. You agree? Remember that? So if I plug in 1, we can immediately see the bottom is 0, so it's undefined. We're good with that? Anyone have questions on that part? No? All right. Now, when we put in 2, f of 2 is giving me 2 cubed minus 1 over 2 minus 1. I will often do the algebra very quickly in my head. If you are lost, like I know you were, just go ahead and tell me. You literally were like, when I did it. It's okay, all right? Students have to tell me every year. Just tell me to slow down. When I plug it in like that, I'm going to get 8 minus 1, which is 7. And then I'm going to divide it by 1, which is just 7. So that's how I did it, okay? Yeah. Yep. All right. Huh? Indeterminate. Undefined means you're dividing by 0. Indeterminate means there's multiple answers.
So this will be both will be correct. 0/0.
Is indeterminate. Indeterminate. Where? Ah, I see what you mean. Because, yeah, you're right. It is both technically correct because of the fact that it is divided by 0. So it's indeterminate, and one of those answers is undefined. I see what your confusion is now. Sorry, my bad. I was like, what are you guys talking about? You can put either. Yeah. Probably undefined is better because of the fact that it's the real problem, right? Is that it's dividing by 0. But yeah, now I understand your question. Sorry, Benjamin. All right, based on what we've seen so far, you guys. Does f of a need to be defined in order for the limit as x approaches a of f of x to exist? No. The function doesn't have to be defined at all, right? Draw and explain two different graphs to justify our reasoning. In both graphs, f of a should be undefined, but in one graph, the limit should exist, while in the other one, it should not. So, let's draw some pictures together. We got two of them, right? In both cases, a needs to be undefined. So, how do we want to do it? We want to make it a whole. Let's just put a right here for fun. First one, we want the limit to exist. So if the limit exists, the easiest way for us to do that, Juanita, what's the easiest way for us to do it? You must know. Exactly. So listen. Thank you. Okay. If it exists, what? I have never been told to talk louder in my life. Usually people come and close my door because I'm talking so loud. I think you're just talking, honey. All right, I'll try. If I need the limit to exist and I'm approaching a, the easiest way for me to do it is to put a hole wherever it is that it's supposed to exist. Probably part of the problem is my surgery and braces. Sorry. So I'm like slurring my words. I apologize. All right. And then it would look like that. Do you agree that this limit would exist?
Yes.
As I approach a, it would exist, but the function doesn't, right? There's no function at a. Because there's no... I'd have to put a dot somewhere. But since there isn't, it doesn't exist. But it's okay, the limit does. On this one, if I want it to not exist, the easiest way for me to do that and do it the same way is going to be to put like two different dots. One of them, because now the left and right side are not going to be equal, right? That would mean it doesn't exist.
Why would it equal?
Okay?
Why would? I'm sorry.
What's it?
Why would it be?
Why would this one not be equal?
Because they look exactly.
No, because here the left side and the right side are not equal. Here, the limit as x approaches a from the left of f of x does not equal the limit as x approaches a from the right of f of x.
Because the limit is defined.
Because it's going to two different points. That's the only reason. It doesn't matter that the graph isn't defined, because over here, the limit from the left and right both equal the same thing. Okay? Yeah. This one, the limit does not exist. Here, the limit exists. In both cases, my function does not exist at a. That's the whole point. Right? In both cases, f of a is undefined. In both cases, right? Exactly, which there is a hole on both of them, right? So in both cases, f of a is undefined. So the function doesn't have to exist. Here, the limit existed, and here it didn't. So the limit can exist even if the function doesn't. That's the whole point that I want you to know. Okay? I feel like I need to move you girls like to here and see if those boys still remain quiet over there. Okay. All right. Guess what? Practice problems. So you guys got the last 25 minutes to work on those, okay?